working. There it goes. All right, this is the Widefield Astrophotography. And basically, it's what I call telescope optional deep sky photography. And I'm Lynn Cromer. If you don't, and you probably don't know me, you may have seen me on Facebook or something like that. Well, you haven't seen me, but you've seen my idiocies going on. And I live between Red Oak and Ferris in Texas, which is just south of Dallas. I know some of you are from as far away as England, I believe. I've been a professional photographer for over 50 years. I've been shooting astrophotography for the past 18 years and absolutely love it. At the same time, I was doing other work, like we did a lot of aviation work. Uh, have an observatory in my backyard. It's about 15 years old. Have 5 telescopes, and I count the 35 millimeter Rokinon as a telescope because that's what I use it for. A 72 millimeter refractor, a 102 millimeter refractor, an 8-inch reflector, and a 10-inch reflector, and 3 field mounts that I carry out to my events. I shoot astrophotography with either Nikons or cooled astro cameras. I have two cooled cameras and 3 Nikons. And I host events. If you're in this area and you want to come, please keep up with my Facebook pages and they'll tell you when and where. I share everything I know, which isn't much, so it won't take me long. All right, this is my observatory, and that's the inside of it right here. At this time, I took this yesterday. I have my 72 millimeter a guide scope and the 35 Rokinon. Both of these telescopes are hooked up with cooled astro cameras. What is Widefield deep sky photography? It's where we use a camera lens from 80 to 500. I'm putting a restriction on this because this is really designed for people that need to be inexpensive and to be able to use what you already own, if at all possible, without having to add too much to it. So I'm going to say that we're going to work from 80 to 500 millimeter. Telescope with focal lengths from 300 to 500 millimeters, and that pretty well encompasses most of the refractors that you can buy, the small refractors, and they're all relatively inexpensive. That 72 millimeter that I've got that I absolutely love is about $450, so it's not terrible bad. DSLR or mirrorless camera, either one. A cooled astro camera, if you have it. If you don't, no problem. The advantage to having a cooled astro camera, one is it cools and it helps get rid of noise, and 2, it doesn't have any filters on it. It's pretty well wide open, and it's designed specifically for astro work. Mounts up to $500 now. And I'll go over those in a minute, but you can pretty well buy a go-to mount used nowadays for $500. In fact, I have one that I bought for $50, an old Meade, and I took it and I added a kit to it to change it over to belt drive and to stepper motors. Absolutely a wonderful mount, and I've got less than $300 in it. Okay, what are our topics? Well, we're going to talk about things for beginners to intermediate photographers. We're not going to get very high because this is a beginning type thing, and I want people to understand and to get interested in the hobby. Talk about how to start out in deep sky photography. Talk about equipment. Talk about software. Talk about basic setup. And talk about shooting. We'll talk about processing next week. I will actually take one image and process it in Photoshop using a new technique that I've worked on for several months now, that I've picked pieces off of the internet basically and put them together. And I'm using a process called arc sine hyperbolic curves to stretch. And it is unbelievable what it does. And by the way, I didn't bring this up, but if you have a question, please type it in and Andy will watch them. And as they come up, he'll give us a holler and we'll talk about them.
Yeah,
So
there's a
please
chat.
ask questions if you like.
Yeah, there's
Go
a
ahead.
chat function that you can bring up. So just type your question in the chat, and I'll relay those through to Lynn. Yes.
Okay. All right. What are my goals here? I want to teach you how to photograph deep sky objects with minimum of expense. That's important. Photograph deep sky objects with or without a telescope. Telescopes not required, they're optional. Photograph deep sky objects with lightweight equipment. In other words, stuff you can put in a backpack and hike if you were of a mind to, which I'm not. Photograph deep sky objects while learning. And I will assure you, if you come to one of my events and never took a picture of anything, I will get you a decent picture of a deep sky object the first night. Not a problem. It's not quite as complicated as it looks, but it is as complicated as it looks. You can make it just as complex as you like, and to have fun, obviously. What type of targets? Well, nebula are the primary targets for the wider lenses because nebulas are pretty good size and they have a tendency to fill up frames. You can't go real deep with this, and a lot of galaxies tend to be rather small, so they kind of don't fit into the frame. Galaxies, obviously, that this is M33 right here, and it was shot with the 72 millimeter, 432 focal length, uh, and it filled it up. And Andromeda and some of those like that actually work pretty good. Star clusters, they're all over the place. And I always, every time I see one of these, I sit there and look and I think, how many stars are in there and how many other universes are there? All right, what's the equipment we're going to deal with? Well, let's start with the cameras. If you have a DSLR, you have a camera that you can do astrophotography with. It's just that simple. There's not anything, you don't have to have a real good one. In fact, just about an hour ago, Trevor Jones of Astro Backyard posted a new video on how to put together a, what did he call it? My cheap astrophotography kit for deep sky. And he's using the cheapest Canon camera you can buy and the kit lens. And he's built a deal out of that. He put the whole thing together, trackered everything for right at $1,000. Go check out Trevor's site. He's very good. And then there's dedicated astro cameras. Now, that's something that you can't do anything else with that camera other than take astro pictures with it. You're not going to take a picture of your grandchild with it, but it's cool. They come cooled or not cooled. You don't have to buy this same camera that you see up here comes either way, with a cooler or without a cooler. The cooler costs a little bit more, but it makes a big difference because I can cool that camera down to 25 degrees below ambient and take a whale of a lot of noise out of it by doing that. Uh, which is in Texas, that's kind of important. All right, let me skip back up to DSLR a minute. I just heard a deal on a new DSLR. It was a Panasonic, and the Panasonic has some sort of a new device in it that lets you track in camera. And a guy posted a picture of Andromeda that was made up of 140-second non-tracked, other than in the camera, images. So that camera tracked internally for 40 seconds each shot. That's impressive. All right, the lens, obviously between 80 and 500. Prime lens is way better than a zoom lens. So there's several problems with a zoom lens. One of which is that the zooms tend to creep on you. You have to tape them down real well, or they'll creep. Zoom lens don't tend to be as sharp uh, as fixed focal length prime lenses. That sometimes that's hard to tell, but they don't, and they have a tendency to have more aberrations in them. We'll get to that in a minute. Manual focus with a tight focus ring is better. If you don't have a tight focus ring, then I recommend you get some gaffer's tape or something and you tape it down. Or I posted a deal on can't think of the name of it now, but anyway, I posted a deal where you cut up bicycle inner tubes and make rubber bands out of them and stretch them and put them around the lens to lock the focusing ring so it doesn't slip and slide, because that'll drive you crazy. Aperture ring. Many lenses now come without aperture rings. It's best if you have one. You don't have to have one, but it's absolutely best if you do. The most popular brands of lenses for astrophotography appears to be Rokinon. I have three, and I know a lot of you have several. Uh, and I see where in some cases people are using the Sigma Art. Now, I can tell you without a doubt, I've got a lot of Nikon lenses, and I cannot use any of them. And the primary reason is because they have some terrible chroma and stuff on them. They're just drive you crazy. And they're expensive lenses. I've got a 14 millimeter we tried to use for a Milky Way, and the darn things had so many flying saucers on it you couldn't use it. All right, and no aberrations. Now, what is that for sure? Well, this is one type. I tried to shoot a 50 millimeter that I had with a 2X on it to just to see how it worked. And it was an old 1970s 50 millimeter. And it had this, what I call comets. I got a fancy name for it, but I call it a comets all around the darn thing. And it makes it to where you can't fix them. They're there and you're just stuck with them. Then the other one are the Space Invaders. That 50 and that 14 millimeter Nikon, all both had this so bad around the edges you thought that we were being invaded. And there is absolutely nothing you can do about it that I'm aware of. Like, you might be able to use the minimal filter in Photoshop and click on the maintain round and force it to be round, but I don't think so. I'm not even going to try. All right, telescopes.
Hey, Lynn, real quick.
Yeah, yeah, go ahead.
We had a question.
Yes.
Can you just talk a little bit more about why cooling is important and the relationship between heat and noise?
Yeah. Cooling is important because the lens, and you're going to find this if you're using a DSLR, by the time you get through shooting quite a few subframes, the camera's going to be hot, real hot. Well, when you heat that sensor up, it tends to generate more erroneous pixels, the little red hot pixels. And it gets really bad and it makes noise to where you can't hardly do anything with it. If you cool that sensor, then it takes that out of the equation pretty well. You still get some pixels that are hot, but primarily the cooling is to improve the signal to noise ratio, is what it amounts to. And we can get real deep into that, but we don't really have time for it. And it's not where this is, but I'd be glad to on a different time. But that's primarily why you shoot a cooled camera is to get rid of the noise. What was the other part of that question, Andy?
And that was the big thing was, why temperature
Okay,
increases noise. So it's the impact that the heat has on the sensor itself. And we just had
absolutely. Yeah.
another, yeah.
Yeah,
And
go
just
ahead.
one other
Go ahead.
comment here, that, the Canon 50 has that Space Invader problem, but the problem, can be decreased by, decreasing aperture a couple of stops.
I
So
agree.
that
Now
maybe also,
here's the problem, several problems with decreasing aperture is that depending upon the iris, how the iris is built, how many leaves it has, you can end up with some pretty severe diffraction stars, where it'll have 10 streaks around them. And that can be annoying sometimes. Another way that I stop down, I leave my lens wide open. Then I put an adapter on the front in the filter where you screw the filter in and choke that lens down. And generally, I choke it down to a 2 inch size, 48 millimeter. So you can screw a 2 inch standard filter in that you can actually use on a telescope also. Well, that chokes it down and helps with that problem, but doesn't give you the diffraction spikes that the iris does. So yes, you're correct. You stop it down and it will help. It also starts taking your time up and up and up and up, as you know, or your ISO on that camera. So yeah, and like I say, the secret to the lenses are the difference basically between a telescope lens and the camera lens is that camera lenses are designed to photograph landscape in reality, and landscape doesn't have bright little stars everywhere in most times, so they don't worry about what happens when the little bright speck comes in there. They don't grind the lens to fit that, whereas telescopes do. That's important. So the lens is ground in such a way that it gets rid of those problems. It's way more expensive to do it that way than it is the way the regular camera lenses are done. Now, I say that, but the Rokinon lens, there's several of them, the 14, 24, and the 135 are all ground intentionally to be used for astrophotography. And they ground them to get rid of the coma and the stuff. So that's that's one of the reasons that so many people use the Rokinon lens. It's that and the fact that they're inexpensive. And part of the reason they're inexpensive is because they're totally 100% manual. There's nothing automatic about it. Although I think they just came out with a new, I believe, 24 that's got autofocus in it. But anyway, did that answer that question?
yeah,
Good.
thank you.
All right, telescopes. 250 to 500 millimeter focal length. Now, focal length is measured funny. It's measured basically the same, but it's measured funny in a telescope. In a camera lens, you can have a 500 millimeter focal length in a fairly short lens. In a telescope, it's going to be 500 millimeters on a refractor or even on a reflector. It's going to be 500 millimeters from the lens to the point which it resolves itself to the camera sensor or the eyepiece, if that's what you're doing. And so that's also another way to tell about where the focus point is on a telescope. And I've not run into a telescope yet that comes from the factory with long enough extension on the draw tube to be able to focus the darn thing. You have to add extension pieces on it, but that's neat. And they do that because people put a lot of gobbledygook between them, filter wheels and all sorts of stuff. But anyway, so 50 to 500 millimeter focal length, 60 to 80 aperture. And the aperture times its f-stop is the focal length. Okay. So you'll see an 80 millimeter at f10. That would be an 800 millimeter focal length. So that's how you find the focal length. And these little telescopes right here, everything you see right there is $500 or below. They're absolutely, I own this Astrotech right here. Not this particular one, but one just like it. And it is a wonderful device, and it was 400 and something dollars. And I just absolutely love it. It's got a really nice size to it, where it frames nice. All right, types of
Hey, Lynn, real
telescopes. You
quick,
have yeah. Go
just
ahead.
one. So we had a question come up on
Good.
lenses. So
Yep.
and this is Alan from Northern Ireland, who asks, with a
Do they have lenses in
2470,
Ireland?
he's got a I think it's the Tamron 2470.
Yep.
And he's wondering if that's any good for astrophotography. I know I've got the Canon 2470 2.8, and I have gotten some pretty good wide field shots with it, Milky Way type shots. But just your thoughts.
Yeah. No. And again, depending on how much it puts the comets or the flying saucers on there, it should work fine. At 24, I use most of the time to shoot Milky Way. I shoot with a 24, and that lens is probably very fast too, so that's good too. So, and then at 70, you can actually do a pretty good job of getting, for example, uh, a lot of nebulas will fit in that. Uh, I mean, a lot of California Nebula and two or three others that'll fit in that without any problem and be about the right size. So, to answer your question, yes, that should work. All right, we've got
The one thing to do would be to probably tape down the zoom ring so you don't have creep.
yes, you got to tape down them all, absolutely. And I'll show you in a minute what I do to fix that. Uh, we have reflecting telescopes, which tend to be big and bulky, and I've got two, and one of them, a 10-inch, it's heavier than I can carry almost, or mess with. And when it was mounted to its forked mount, some people call it the forked devil, uh, I took it off of that because it won't track anything. And it was so heavy that you couldn't carry it outside. So these, like I say, they tend to be a little bit on the heavy side. They are, in most cases, longer focal length than what we're talking about here. There are some small ones that get down into our focal length, but because we're restricting it to 500, these probably aren't going to work. In reality, the best, or some of the best telescopes for photography are the reflecting scopes. Uh, but they're extremely expensive because the lenses are ground so the mirrors are ground so well, and it's so built so. It's not uncommon to see a 12-inch mirrored reflecting scope run $20,000 just for the scope. But anyway, we don't want one of those. Refracting, I think, is by far the best for this type of photography. It's lightweight, fairly lightweight. They easy to carry around. They don't overload a mount. They keep the mount to where we can use smaller, simpler mounts, and they have great focal length, and the clarity and quality of the image is extremely good. And we don't have the problem with these refracting scopes that we have with the mirrored scopes, because mirrored scopes have to be collimated constantly. Every time you bump it, it knocks the mirror out of whack, and you got to go in there and readjust it. Whereas the totally the refracting ones, it doesn't, nothing gets knocked out. It can get out, but it's very, very rare. And you probably have to send it off to get it collimated. But these also, as I was showing you before, are also well within the price range that most people can start out with if you want to go to telescope. And I guess you could use them for shooting other things. I wouldn't recommend it. They don't have an aperture or anything like that. They're just wide open all the time. So, and like I say, I've got two of these. I've got a 72 and a 102, and the 102 is just gorgeous. But right now, this is nebulous time, the larger objects. So I put the smaller scopes on. I'll change over when it gets to be summertime, when it becomes galaxy season, and I'll put a larger scope on there to shoot the galaxies. But I still, my favorite target is a nebula. Okay, this is Nina. And all I'm doing is I'm showing you here. This is a Orion Nebula with a Nikon 500 D500 and an 80 millimeter lens. This is the framing that you get with that lens, that setup. Now, uh, you go down and we're going the same camera, 135 millimeter lens, which is the Rokinon lens, basically. Nice framing. And actually, if you turn this vertical, uh, you get the horse head and Orion fits in there beautifully. And I've shot that before, and it's a very nice setup. All right. So then we go to a 200 millimeter lens and see we're getting tighter and tighter on this. 300 millimeter, and we're getting pretty tight. And then if you go maximum to the 500, you can't hardly get it all in. Now you could turn it vertical and probably get it in, but there's a lot of nebulosity outside of there that you'll be losing. And one thing I want to say about lenses, for some reason, well, I was the same way. Everybody wants to start out, and the first thing they want the biggest telescope or the longest lens they can find. I'm telling you, you absolutely multiply your problems tenfold by just going to 500 millimeter. Finding a target in the dark with 500 millimeters is just a nightmare. Getting it focused is a nightmare. It the least bit of wind makes it shake and you lose all your images. There's a whole lot of problems with going to the bigger telescopes or the longer lenses. I recommend that you start if you want to do good deep sky with let's say the Rokinon 135 or something in that range around 100 to 150. Easy to find a target, easier to focus it, easier to deal with it all the way around. And don't make your life so complicated that you abandon the hobby because you can't succeed. And I'm guilty of that. I'm living proof of it because the first one I bought was an 8-inch reflector, and I spent night after night just trying to find a target. And that was back before we had this marvelous thing called plate solving, uh, where the computer would find it for you. The We had to look through it, and it was just terrible, and you just couldn't figure out where it was. You didn't have good camera setups where you can actually shoot a picture, and it comes up on the screen stretched. You couldn't do that back then. But again, I recommend start down around 150 millimeters, and everybody goes, "Well, I can't take a picture of anything." Bull. You can take a picture of a whole lot at that. Everything that you see on this presentation today, all the images were shot with 135. So you can do a lot. All right, the mount. Now, the first thing I'm going to tell you is unless you have a Panasonic camera with that special tracking in it, you're going to have a mount that tracks. And that mount can be either a simple one that's called a camera tracker, and we'll see what those are, or a complicated one which has go-to on it, which makes life an enormous amount different because it allows you to use plate solving and let the computer find your target for you. But for this purposes of this program, we're going to hold it to under $500. We're going to do a camera tracker or a go-to mount. Uh, if you can afford it, I recommend the go-to. Life's much easier. Trackers work great. I have all of these, and the tracker is really wonderful. It's got its limitations. Uh, Watch the capacity. People, I constantly see on Facebook people that have a one of the tracking mounts, a camera trackers, and they have 50 pounds worth of gobbledygook hanging off of it and can't figure out why it doesn't track right. Well, they're designed to hold considerably less than that. And repeated, you go to you they go, well, I don't know why it won't do tracking right. And you say, well, it's because you got, way too much weight on the thing. Oh, no, it's balanced. Balance doesn't mean anything. That motor and gearing has to lift the weight. And if you overload it too far, then guess what? It strips the gears and then it's worthless. Get counterweights for sure on any of them because a lot of people will run the camera tractors without counterweights, and up to a point that's probably acceptable. But you really need counterweights, and then you need to balance the tracker per the way the instructions say. I, however, always balance just a little bit heavy to the weight side because I want to keep some tension on those gears, not a lot, but some tensions to keep them from the slack in them from bouncing back and forth, which I've seen before. Uh, Check the used market. Again, I've got I've actually got two of them. One of them's not built yet, but I bought two different Mead LX70 mounts, older mounts that didn't work anymore. Well, I didn't want them to work because I stripped the motors out of them and the electronics out of them. And there's a company over in somewhere overseas, Hungary or somewhere like that, Lithuania, I think. I don't know, one of those countries. There's a company that builds a system that bolts right on to that particular mount. That was kind of a standard mount. Different companies put different names on it, but it bolts right onto it. That converts it to belt drive, gets rid of the gearing where well, they still have some worm gear in it, but gets rid of all the other gearing that's got slack in it, and puts it on belt drive and stepping motors, and then runs it with a program called EQ Mod, which has been around a long time. It's kind of an open source program that does a wonderful job of running telescopes. In fact, if you buy a Skywatcher telescope, it's run off EQ Mod. Uh, but it turned that scope in from something of no value, basically, into a really fine mount with total go to and everything. Now you have to run it with a computer. It doesn't even have a hand controller. But check the used market. You'll find a lot. I bought one whole telescope, a 10-inch mount, everything off of there, off of Craigslist for $400. So there's some bargains out there. This is the littlest of the camera trackers. This is a mini. It's built by, I believe, Ioptron. I think everybody has some minis, some little ones, but it's got a 6 pound capacity. That's what you have to watch for. And weigh your cameras. I weighed a telescope with a D500 on it the other day, and it was 7 pounds. So you better be careful because otherwise you'll strip the gearing out of it. This is a nice scope, nice mount right here. I really like this. I wish, in fact, when I bought mine, I bought the Star Adventurer. When I bought mine, I had bought this iOptron. I've got my main mount in the observatory is ioptron, and I really like the ioptron. But this one right here, it may be sorry, I don't know, I've never used it, but it sure looks good. I like things that look good, and it's got an 11-pound capacity. Now here's the sleeper of them all. This is the ioptron Smart EQ total go-to telescope with 11-pound capability, under $500, brand new. It's really a very nice mount. You have to tune it some when it comes. The Chinese didn't do a very good job of some of the things in there, and you have to tune it some. Actually, mine's semi apart out there right now. Is getting it ready for this year. Uh, and I'm going to run this with a off a computer. I run everything except my tracker with a computer. I run the cameras through the computer, and I'll show you why in a minute. But I'm going to control this with the computer, this little $500 mount, and it does complete plate solving where you can point it at the sky, take a picture, say solve that, and the computer looks at it and says, okay, we're pointed XYZ, and it sends that coordinates to the telescope and says, you need to get lined up with me. And then you tell it to go somewhere, and it goes to that point, and it takes another picture, and it looks at it and says, yeah, we're off about a half a degree, and it moves the scope a little bit, and it'll dead center it without even asking. I mean, just within a matter of few minutes. And so that's the one I'm going to use. Now, I also have for my Astro tracker, my little one, I built a 3D printed adapter that a green laser goes in, and rather than getting to on my hands and knees to polar align it, I just turn the laser on and point it at the North Star. That's close enough because I'm not going to take deep sky much with that. So that works pretty good. All right.
Hey, Lynn, real quick
Yeah,
question
go
here.
ahead. Yep.
So can you talk about using the lenses that you discussed on full frames versus crop bodies?
Okay. Yes. Let's go back and let me go back a ways. Okay. Right here, one of the tools that I use to determine a target is Nina. It is an absolute. It's got the best setup for finding a target and centering on it. And I can move that. I can't on this, but it's because it's not live. I can move this around anywhere I want, this box around, and put the subject off to the side if I want to. And then I go over here and click slew, and it tells the telescope, and it moves it over there and plate solves it, and it puts the frame exactly where you have it on this picture. But
and that's essentially, you've got your computer hooked up to your camera, and
absolutely.
So that's essentially live view.
Yes.
So whether you're a crop sensor or
no, now no, it's not live view. This is a picture.
Right.
The what I do is I have several telescopes that are available to shoot this wide field. Let's just say, and mainly I just use two of them, the 72 millimeter and the 135. I can come right here and I can program in the focal length right here, whatever it is, and then you put in the camera sensor dimensions here, the width and the height, and then the pixel size, and then your focal length, and it calculates the little frame for you. And what I do is I get a target, and then I start trying the different options I have, which are the 3 different cameras with different size sensors. Well, actually it's more than that because it's 5 cameras. I have 5 cameras, and not 2 of them are alike. And you can program them in, and you can see then what the framing looks like, and then now select the camera and the telescope based on what I see right here and what I frame right here. Uh, and I usually do that sitting in the house, running Nina in the house during the daytime and pick the targets. Then I go out the observatory, and all I got to do is just plug in the information for the target. But uh, you change the sensor size, it changes the frame. You change the focal length, it changes the frame size. So it's important that you know those that information and uh, have a method of plugging it in. Now there are two or three other places on the internet you can go and get a similar setup like this. But I prefer just to have Nina, and Nina is absolutely free. You download it, put it on your computer, and you can use it anytime. But so the answer is yes. The sensor size does affect the frame size of your photograph. And you just have to play with it to figure out exactly which one you want to use or what it looks like, or if you can use it at all. I mean, you may be so tight it won't work, or so loose. I've seen a lot of cases where I was so loose. I said, "Well, I'm not going to waste my time with that. I can't crop that out." So I just gave a simple
But
example of changing the focal length, but the sensor
mhm,
size is critical. Does that answer it?
yeah, but the bottom line is you can use, a full frame DSLR or a crop sensor. And again, from my experience, I'm using Canon gear and 7D Mark II, which is a crop
Yeah.
sensor, and I've gotten some great astrophotography
Oh, well,
images with that camera and sensor.
again, a lot of people get all hyped up over how many megapixels they've got. That's not altogether true. You look at these dedicated astro cameras, and the majority of them are rather low megapixels, but they're high quality pixels. And there's also some algorithms that you can plug things into, and it'll tell you that for this uh, lens, use this pixel size. And I've tried that before, but I talked to a camera rep one time, and he said, "Well, that's if you're really going to get picky about it, yeah, you can do that, but basically no." But I have found that I have this camera that's right here is a D500, and it's got a 4.2 pixel size, pretty big actually. I've got another camera that has a 3.8 pixel size. Then the one I use most of the time, my ZWO, has got a 2.4 pixel size, and the sensor is basically one of those 3/4 sensors, similar to a crop sensor. Uh, and I use it a lot, but I'll swap it out with my QHY camera that's got the 3.8 pixel size because it makes the frame bigger. So there's all sorts of little ways you can manipulate it. Of course, if you have one camera and one lens, you dance with who brung you. That's about all you can do. Okay, did we get that answered?
Yes.
All right. There are DIY mounts. You want this is a and I built some, uh, and I can't find a picture of them. Anyway, this is a DIY mount. You can go on to Instructables, and they have a whole bunch of them up there, and they can be built fairly inexpensive. Uh, if you're handy at all, they work. I mean, what can I say? They're good for at least 2 minutes, which isn't bad. This one, on the other hand, and it came from Instructables too. This is a 3D printed uh, full uh, equatorial mount. Doesn't have the declination on it, but I actually have printed this and I have it out in the shop, and it's almost finished putting it together. And I really, really like this. And I'm telling you, you can probably build this If you have a 3D printer, or if you have a friend that has one, or if you're like David was, he just beats his son up and makes him print it for him. Uh, it makes a beautiful mount. So I've nearly got it finished. Like I say, I just haven't had time. I've been working on this, but I highly recommend that DSLR uh, mount. It's called 3D Adventurer. It's on Indestructibles. All right. So there's other ways you can do this way cheap. I would say you can build either one of these mounts for under $100. All right, camera control systems. How do we control this camera? We're going to be shooting long exposures, so we need to have a control for it. Intervalometer. This is the simplest, cheapest, easiest way to control it. This is what most people do. You can buy these real fancy that are wireless and blah, blah, blah. This particular one is wired. It's on the Amazon. It's by Newer, and it's 1995. And it does just about anything you want it to do. The way that here's the way I look at it. If you don't have anything better, use an intervalometer and it'll work great. I recommend, if you want to have better control and learn this better and faster, you use a computer, use a laptop to control the camera. If you have a mount that can be controlled, use a laptop to control the mount. Even the star trackers, the camera trackers nowadays have a port for guiding. You need a computer to do that, and you put guiding on one of those, and they're bound to be really, really good and sharp. In fact, I saw a guy that was shooting 5 and 6 minute exposures with a sky tracker and a guide camera. The computer makes it easier to focus. One of the huge problems you're going to see that you have is focusing. And I'll show you what I recommend to do as far as focusing is concerned. Uh, See a stretched image as you shoot. I'll show you an example of that in just a second. But you, what comes in basically in the raw version is pretty well black with a few white spots on it. If you use a computer and you control it, for instance, with Nina or with SharpCap or APT, for example, some of those programs, or if you want to control just the camera, if you use Nikon or Canon Backyard, that's another good program. They don't stretch, but the the programs that are built for astrophotography, when they bring the image in, they stretch it for you so you can see what in the heck's in that picture. Otherwise, you can't. Software that we use is SharpCap. It costs money. APT, it costs money. I've used both of these extensively. Uh, I never was satisfied. I always felt like they were old technology. Uh, I don't know why. They did work and they didn't do a bad job, but they didn't encompass everything, and it just seemed like it was old and slow. And NINA, which is nighttime imaging in astronomy. I ought to be an ambassador for this because this is absolutely, to me, it's the dream program. I'm sure that tomorrow there'll be something else out that will be better, but this one encompasses virtually everything under one roof, and it'll let you. It's got all the tools are right there, whereas a lot of the other ones, you have to have one tool over here, one software, and then another piece of software over here, and another one over there, and it drives you crazy just trying to keep them all running. Uh, that's why I've really fallen in love with Nina, and I use it on everything. I've got my observatory has two scopes and two computers, and they both run Nina. All of my field work is going to run Nina now with a laptop out there to run it. Uh, or you can get these new little mini computers and run it but you have to have a screen and a keyboard. But I highly recommend that you go to that and to stick with it. And it's free. It doesn't get any cheaper than that. All right. What the computer can do for you is it'll polar align. Now, you can polar align just with the camera or the scope, uh, and it does a fairly good job. I use a pole master to polar align. There's another one that's I can't remember. I think iPolar. No, Skywatcher has one out now. It almost looks like the same machine with a different label on it, but it's a camera set aside that takes pictures of Polaris and the stars around it, and you select the stars around it and rotate the device, your mount, and it figures out where the center is, and then shows you how to twist it and turn the knobs to make it come into exact polar line. And I'm telling you, you can make it dead on with those. I've built mounts for all of my other uh, or built a mount for the pole master to go on all of my other mounts. So when I'm out in the field, I still use a pole master. Cause I'm getting too old to get on my knees and look through that polar alignment deal. Focus assessment works great there. Uh, One of the things that you'll find out is it's very difficult to focus on the back of a camera. It's just entirely too small to tell what the heck's going on. So I want everything on a screen. And worst case, even if you do not uh, run your camera with a computer, uh, pull a monitor off of something. I've got two or three 12-volt monitors that I can plug into a battery and just plug them into the camera. My cameras, Nikons, have all got HDMI ports, and they go right to a monitor, and it puts what you just took a picture of on the screen. Well, that gets the stars bigger, and you can tell whether or not they're in focus or not. Histogram, you got to have a histogram. I know that a lot of people don't use histograms, they're not used to it. And in reality, today's DSLRs, you really don't need a histogram. I mean, that camera's pretty well dead on the money as far as exposure. But you start doing astrophotography, that's a different animal. You got to have a histogram to tell what exactly is going on in that image. Stretch images for viewing. When you use a computer, when the image comes in, it's raw, and the computer then automatically runs a stretch program on it to get it to where you can tell what's in it. Plate solving. I've explained a little bit about plate solving a minute ago, but that's critical too. I mean, it literally puts it dead on the money. Wherever you have that little box, it'll set that telescope right on it. And scripting. I was talking to a guy a little bit ago about shooting M42. And M42 is that's Orion. It's funny. It's got an extremely high dynamic range. And to shoot it properly, you actually need to shoot multiple sets of exposures at different times to get the center of it where there's 3 or 4 stars in the center. And to get that to where you can see them, you need to have a very short exposure. Then the external outside, you've got to have real long exposures to get the nebulosity to come in, to get enough pixels to be able to see it. And so what you do is you shoot these multiple. And for that example, I shot Orion the other day, and has to do with camera and lens, obviously. But let's just say I shot 5-second exposures for the core, and then I shot 30-second exposures for another part of it, and then I shot 1-minute exposures for some more, and I shot 2-minute to pick up the very, very faint stuff on there. And you go through there and process each set of pictures, and then literally run them through Photoshop or Lightroom HDR. and it makes a beautiful image. But scripting will allow you to set the computer up to tell the camera and the telescope, I want to shoot 5-second exposures and I want 30 of them. And I want to shoot 30-second exposures and I want 30 of them, and so forth. And you can set those up and it will then do them one at a time, go down through it. And actually on scripting and plate solving, you can say, now I want you to move to XYZ uh, target, and it will move the telescope over there, plate solve, and then start back shooting. So they're very handy, but then they can get real complicated. It's something you've got to start simple and learn this as you go. It's not something you learn overnight. All right, and select targets. That's Nina only that's got that ability, like I was showing you, to have a picture of the target and pick it. And I'll show you some other stuff in a little bit. And to guide. Uh, Guiding is actually controlled by a program called PhD2. And that's not doctor, that's push here dummy. And it's a fantastic program. It's absolutely free. You hook a guide scope to it and it snaps actually in at intervals of, I use 2 seconds, snaps a picture of a star. And if it moves a little, then it adjusts the telescope mount to put it back on target. And it will hold the telescope mount on target to with 1 pixel. So it's pretty nice when you can get it to work. And when you if you ever get it to work on one, it works great. All right. You might ask, what is stretch? If you don't mind, I'm going to take a short break. I'll be right back.
While Len's taking a quick break, one of the terms he's been mentioned a couple of times is plate solving. And if you're not sure what that means, um, there's this database of deep sky objects and stars and all of their positions. And with plate solving, what these software packages do is essentially compare the image that you've taken, and it compares that against that database to figure out where your tracker is pointing. And so you don't have to, look around and try and find things manually. The computer talking to the mount does that for you. And like I said, that technique is referred to as plate solving.
Yep. All right. I'm back. All right. You might ask, what is stretching? This is an image right off of the camera. Can you tell anything about that? I can't. That's what pops up on your screen, and you go, well, is there a target in there? I was trying to shoot the Heart Nebula. Where is it? Well, that's what normally comes up. The computer has a little routine in it where it does a one-time stretch. You can adjust it, set some values to make it better. And so it fixes this so where when it comes up on your computer screen, you get that. And that's simply by just it stretches that. Now, this particular one is probably stretched a little bit much because I've stretched this myself in Photoshop. The one on the screen generally is not quite this stretched, but at least you can figure out, is the target in the middle of the screen, or where I want it. And I'll tell you a funny little thing. In this particular image, I've cropped this a little bit, but over on the right hand side, and it doesn't show here, but this is shot with a ZWO ASI camera, and they have a really bad habit of having a amp glow over on the right hand side. This one doesn't show it very much, but a lot of times that can be really uh, kind of a pain. So I literally will move the target to the left side further over to get it out of that. But uh, this is what you get to see on the screen in lieu of that. And you can't tell anything. Now the computer can read those stars. It just looks at the stars, and it don't ask me how it does it. It figures out triangles and figures out where in the sky you're looking. But that's plate solved. Then that come back. That's finished. That's after I processed it. So spam. All right. My basic field setup. What do I, this is very basic. This is a tripod, camera and lens, or telescope. I've got a little telescope. I probably wouldn't run much of a telescope on here. What I would probably run on here is just what you see, a camera and lens, simple little short thing. Although I wouldn't hesitate to put the 135 with the either the D500 or the Astro camera on it, one of the Astro cameras. So I run a camera or a lens, a mount. Now, I'm going to say something. If you don't have a Panasonic camera that does in-camera tracking, you need to have a mount to do this kind of photography, because the exposures, you're rarely going to get an exposure less than 2 minutes. Uh, Most of the images you see on the left-hand side of the screen were shot with 5 minutes, 3 to 5 minute exposures, and 30 minimum. They claim don't go past 30 because they're of no value. The signal to noise doesn't diminish, doesn't change enough after 30. One of these days I'm going to figure out how you measure signal to noise, but I haven't yet. So you have to have some form of tracking device, whether it be a little tracker, regular go-to mount, or a barn door, or a Panasonic camera. A sturdy tripod, obviously. I say a small little table. This is a little camp table. It came from uh, the academy. It folds up, goes in my trailer in the little compartment right there, and a chair so you can sit down, uh, and a laptop. Now, in some cases, I've actually got two little small computers, Windows 10 computers that are little bitty things, but I've kind of got them in. I put them in the observatory because you got to have monitors and keyboards and all that stuff. It's way easier to use a laptop, and it doesn't have to be a good laptop. I bought this laptop at an estate sale a couple of years ago for $10 because the Wi-Fi had gotten lightninged out, and the battery pack was not good. I bought a battery pack for like $20 and stuck this little card in, and it's Wi-Fi. Now it's as good as it ever was. A compass. You've got to figure out where north is. A small light. And I can tell you, if you come to one of my events, you better not have a red light. The problem with red lights is that we have people who shoot nightscape photography where they have landscape and Milky Way in their pictures. You turn on a red light within 10 miles of a nightscape picture, and you're going to ruin everybody's picture because that red light reflects off of the landscape horribly. And so if you have a white light, small, very small white light, it may reflect off the landscape, but that doesn't do anything except help the exposure. So we ban red lights at all our events for the past few years, strictly because of that. It everybody got tired of having ruined pictures because some guy's headlight on his head was shining all over the darn place. So anyway, little small light, I call them keychain lights. They work the best because all you got to do is go look at something on the camera or something like that. You've got a computer. And in a lot of cases, uh, you might want to put this, take just a plastic storage box you get at the Dollar General store container and stick it in the computer into it so it's not glaring on half the world. But that depends on where you're at. A level, because we need to level this tripod. Optional equipment, a finder scope of some sort, if you're a man to, a guide scope. Now, a guide scope is a small, basically a finder scope without a lens in it, without an eyepiece in it, and it's got another camera in there. And that camera is the one taking the pictures of the stars and sending it to PhD, and PhD's analyzing it and watching a star, and it holds it, like I say, within 1 pixel. PhD just came out and I started running it and I love it. A new program that not only looks at a main star, but then it also looks at 4 or 5 other stars in the image, and it keeps all of them steady. And I'm telling you, it makes that scope dead on. It rarely tracks off a half of a pixel. And it might go off a half a pixel, but it only does it for just 2 or 3 seconds, and it's drug it back. A battery pack, if you're running for a long time, you probably want to hook uh, your mount. And most mounts don't have batteries, although every one I showed you a minute ago has their own internal batteries. I never trust them. I think I waste tons of AA batteries because every time I go out, I put new batteries in, and I may not have run it 10 minutes. So I seem to be wasting it just to be safe. So I also carry battery packs, special battery packs. And you can buy these with inverters in them and actually plug computers into it because they've got 110 coming out of it. I run the mount off of it, could run the computer, and I definitely run a battery eliminator for the camera. And you can buy those from the camera manufacturers. There's also on Amazon, there's some aftermarket ones that I think are pretty good. I take the battery eliminators and I convert them. Probably shouldn't even say this. I take and put a converter to get the proper voltage, which is depending on the camera, but mine's like 7 something volts. And I plug it into 12 volt and drop it down to 7 with a little converter. And so I can plug it into the big battery. Now, I also will carry just a regular old everyday Walmart uh, lawnmower battery. They're 20 something bucks, 12 volts, and they'll last a lifetime as far as running down. All right, a storage box to shield the computer, like I said. Bug spray, you don't want to miss the bug spray. All right, tools to help plan the shoot. Clear Outside app. These are apps mostly. That's a critical one. You need to go get that because that'll tell you if it's going to be clear tonight or not. Handy. I use that. Actually every morning I get up and I check the weather, and then I check the clear outside to tell whether it's going to be clear or not, so I'll know whether I can shoot that night. Stellarium, great app to help you find where your target is if you're not running a computer. Dark Sky app, that's a program that tells you how much light pollution you have in any given area in the entire world. There's another program called Light Pollution. Dark Sky app does not use Bortle scale, so you can't translate it into Bortle scale, whereas Light Pollution app does. use a Bortle scale. And so it relates closer to what you see in a lot of places. Dark Sky app is still great, and that's one I use most of the time. But uh, when you live where we live, there's not many spaces that isn't a five or above around Dallas. Phases of the moon, that's very handy because you don't want to shoot uh, during when the moon's out unless you're shooting filters, narrow band filters. With a narrow band filter, uh, you can shoot right next to the moon and not have any problem because it blocks out all the light except the light you're looking for, which is usually hydrogen alpha or oxygen or sulfur. And there's a filter called L uh, uh, enhanced, and then they came out with a new one that's L extreme. They both show hydrogen alpha and sulfur, or I mean, oxygen 3. Uh, One of them, the one's less money than the other one, and it's less money because it's like 7 nanometers, and the other one's 3. But it just better. But there, I use them. I almost always use them on nebulosity. Photo pills is primarily for Milky Way shooting, but it's an extremely good program for determining where the Milky Way is, where the sun is, where the moon is. Unfortunately, it doesn't tell us anything about deep sky objects and Nina. I think I've preached the benefits of Nina more enough. How do I plan a shoot? All right. This is the Nina program that's, I'll try to go fast because we're running over our hour limit. Well, I don't know that we had a limit. Well, we're running over an hour. Uh, Sky Atlas. And one of the beautiful things about Sky Atlas that I use all the time is you click on objects here and you go down and say, I want to see bright nebulas, diffuse nebulas. You don't want to do the LMC unless you live in Australia. Uh, Planetary nebulas. And then you click on search. And there is everything that's available right there. And then you could come over here, and this little arc right here says this rises at 7:30, and it's at its peak at midnight and sets at what, five something. So you can tell when it comes up and when it goes down, and you can scroll down through this and you can find things like California Nebula is absolutely at peak at about 7 o'clock. That's straight up. Then you come over here and you say, send it to framing, and it sends it down to the framing program, which is where you have your camera set up as far as your sensor. And this is set up for the QHY and for my 72 millimeter scope. And you can pull it up and you can go, ooh, that don't fit, does it? So California Nebula is pretty big. So let's take it and we go back over here and we'll change this same camera, different scope. We'll put the 135 in there. Now it fits. So I used the same camera, changed the lens on it, and it fits. Then I could do the same thing by changing the camera to my ASI, for example. And I can't show you this, but I have a chart where I have all the specs for the three cameras, two cooled cameras, and the Nikon 850 and the 500. I don't use the 800 much in Astro. I don't know why. It's not my main camera. But anyway, and I can just plug in that information and determine where I want it. Now I can say, okay, I want that because I know that one camera puts the mess over on the side, the amp glow. Uh, I'll move it over like this and say, okay, that's pretty good framing. When I crop it, it'll be just about right. And I've cut out all this amp glow over here. Then I just click on slew. and it will send the information to the telescope, and the telescope will go over there. Then you go tell it, plate solve it, and it will plate solve it and put the California nebula right there every time. It might move twice, but that's usually about all it'll move. So this is extremely handy. And like I say, you can go back and say, all right, let's do something else and pick other targets if that one didn't work. And see, here's a good one, Rosette Nebula. That's actually the targets that I'm working on right now. If I ever see a blue sky again, but if you look, it's perfect. I mean, it's I can shoot both directions. I can shoot uphill and then shoot downhill. And the camera, I mean, the telescope will actually get vertical where it's pointing straight up, and it'll say, well, that ain't going to work anymore. And it will flip and it will go move the camera and everything to the other side of the scope. So it's working downhill and it will track it. Where I live, downhill is not terribly good because I start getting into glow from the night sky. My best sky is southeast, but I've shot a lot of downhill stuff. You can shoot a couple of 3 hours this way, and that's about it. But this is a fantastic way to pick your targets and to set it up. And I might pick two or three targets in one night, and then go out there and see what they look like and whether I like them or not. And then if I don't, I'll move to another one. All right. Enough preaching on Nina. Okay, so I showed you how I pick a target. There's other ways to pick a target also. Uh, there's all sorts of books that have. There's one that's got 100 targets in it. Very good books. There used to be, and I'm really disappointed that it went away. There used to be an online magazine several years back, and every month it had an article that somebody wrote, and it said what to shoot this month. I saw something the other day where somebody had one up. What narrow band target to shoot this are available this month? Well, a lot of them won't fit in our camera size or our telescope size because we're restricting it down to a smaller. You'd have to get a bigger telescope, but a lot of them do, and there's a lot of them right now that are just fantastic. One that is really cool and it works great for my 72 millimeter, which is 432 focal length, is the M1, which is the Crab Nebula, and it is gorgeous. It's a little bit small, but it's all right. But it's so faint that it's going to take probably 10-minute exposures to get enough detail to make it work. But it is beautiful. It's reds and blues and greens. Beautiful. All right, what do we set our camera to? All right, manual mode, period, manual mode. Shutter speed set to bulb. Autofocus off. Long exposure noise reduction off. You have to go into the menu to find that and turn it off, because what that does is it really slows down the download time because it's going in there trying to denoise it. White balance set to daylight. It doesn't really matter, but I always set it to daylight because you can adjust that later in camera raw. ISO 800 for a start. The primary shooting challenges are target acquisition, drive you crazy. But one thing I can tell you, if you got a zoom lens, zoom it out. Find your target, then zoom it back in on your target, because nothing more frustrating than having two stars in the field in the image and you don't know where that is. If you don't have plate solving, that's where plate solving is extremely handy. Focusing, that's difficult on the back of a camera. There again, plug it into a computer and get it bigger, or plug it into a separate monitor. Even the little 7-inch screens you can buy for little or nothing that plug in, and it'll make it bigger where at least you can see it. Exposure. Exposure is kind of a game. You have to just start exposing until you get it to where you want it. And I'll show you way I start. Polar alignment. That's not very difficult if you go online on your phone apps, and there are some polar alignment apps on there that will show you that for today and at this time of day, the the star should be in this quadrant of the little circle. And if you do that, and you're not old like me, and you can get on your hands and knees and look through the polar alignment scope, it's not that difficult to put it on polar alignment. It's really not. And that's another thing I didn't tell you a minute ago. When you uh, set up your tripod, I highly recommend you keep it short. Not don't extend it all the way up. The wind will start wiggling it. You can bump it, all sorts of horrible things. And that makes you have to get on your hands and knees to do just about anything. Focusing. There's several ways to do it. One is with a loop, and that's nothing more than just you can get one of these little $5 plastic 10x magnification loops off Amazon, and you just put it on the screen, primarily for use for the back of the camera screen, and you zoom that screen out as far as you can in your camera, and then you look at the stars. And if you don't have a mask on it or anything, you make the stars as small as possible. That's HFR, half whatever. It's this is basically small stars, where you make it small stars. The computer, Nina, or any of those programs I told you about, will run a routine with a autofocuser, not your camera autofocus, but with an autofocuser on a telescope, and make the stars as small as possible. That's one method of doing it. Then the Betnoff mask. That is the method of choice for just about anything. Now, if you're shooting Milky Way, or you're shooting below about 100 millimeters, maybe 80 millimeters, it's still not going to work real good. But this is a Batnoff mask. This is a mask that I designed and printed, 3D printed. And if you want to print this, I will give you the STL file. All you got to do is email me, so I'll have an address, and I'll be glad to send you the STL file. This particular mask is 100 millimeters square. It'll fit in the 100 millimeter filter holder, or you put some little computer standoffs in 3 millimeter computer standoffs in this slot, and you adjust it to where it fits around the lens, and you just stick it on the front. Then you turn it on, and the stars, this is showing focusing on a star. And you see this vertical bar passes through the X. That's uh, that's what we're trying to do, is we're trying to get the vertical bar directly in the center. So it coming over and goes center. And after a while, you'll learn that if the bar is on this side, you turn the knob this way. And if it's on this side, you turn it the other way. But this is the target to centered. And when you get this into the center of the X's, you're focused, period. All right. I think you need to have some form of an assistant. This is my 135, and I built these rings to go on it, which this one's clamped to the focus ring, and the other one is just clamped to the tube of the lens. And I put an adjustment screw so I could adjust it back and forth to get it in focus, because it's very hard to focus one of these, any lens like this, by hand just on the tube. It's difficult to make small movements. So I built this, and I spent a lot of time and effort to build this darn thing. And when I got it in focus, I've never had to change it. It's locked. Or I've used this type of a device too, which clamps on the focusing ring, and it's got a little bar, and that makes it a lot easier just to slightly move it a little bit. So either one of these, and there's several other ways. I've seen ones that are, and I've built one. I actually have one where it's motorized focus, and it's the computer does it. I've got to where I only use the button off mask, and that you can't autofocus that. So I hand focus it, and it works fine. It doesn't, like I say, this 135. Once I set it the first time, I've never had to change it. It's all every time I turn it on, it's in focus. So I recommend that you get at least one of these. You can buy this little ring and stick thing on Amazon, and they're like $8 or $9. Nothing. Uh, let's look at starting exposure. Set your time for as long as you feel comfortable. The longer, the better. But here's what happens. If you're in a light polluted area, when you set it for a long time, it starts showing up a lot of light pollution. So you need to play with that and figure out where you feel comfortable. Then shoot a test at a lower ISO, say 800, start at 800. Adjust the ISO up to get a good histogram. Many short exposures are not as good as fewer long exposures. That contradicts what a lot of people will tell you. Oh, you can shoot 100 2-second exposures and it'll be just as good as one long one. No, it is not. And if you don't believe me, go to Galactic Hunters on YouTube, and they have a YouTube deal that's called Short versus Long Exposures for Astrophotography, and they just kill that theory totally. And I knew that a long time ago. You shoot a short exposure, and you are not getting a lot of the real deep, faint nebulosity. Uh, like I say, I don't shoot anything except perhaps Orion less than 2 minutes, less than 3 minutes most of the time. And usually I've got to where I just start at 5 minutes, but my night sky will handle 5 minutes. So be careful and be aware of that. Don't buy that short exposure deal. All right, this is what your histogram would look like on the back of your camera. Doesn't look like what you're used to seeing if you ever look at one. We've just got one little spike, and sometimes that spike is so thin that it just looks like a line. Now I pull it up on my computer screen, so it's more this size rather than the back of your camera screen, which is going to be smaller and harder to tell. But the keys to it is you need to make sure that there is a little bit of gap on the left side between the spike and the wall. When it's on the wall, you've lost all that data, and that's dark data. Then this particular one shows a little spike out here for bright stars. Generally, I don't see that spike. What I do see is a little bit of a trail running down, oh, maybe halfway across, and that's the stars. But we're not paying attention to that. We're only paying attention to getting this spike off of the left wall. Now, if it's over here and climbing the right wall, we've got an issue also. So you need to shut the either exposure or the ISO down to try to get it off of either wall. If it's on the wall on the left, you up the exposure of the ISO. If it's on the wall on the right, you lower the exposure of the ISO. And you tweak those until you get it to where it's pretty well right. Now, I can tell you that after you shoot for a while in one location, you will learn what an exposure that'll work will be. And you'll learn how far can I go as far as exposure time, remembering that exposure time is critical. Now, ISO, you can run the ISO up, but all you're really doing, you're actually getting more signal, but you're also generating more noise. And noise is a killer because you'll get, especially with the shorter lenses, they take a picture of a lot of stars, and start having a hard time telling which is stars and which is noise, and you'll have a sky full of stars. All right, the next thing is stacking. It's pretty close to the end, guys. Shoot multiple images and stack them for signal increase and noise reduction. It's proven that it works. Shoot multiple 5-minute exposures. Experience shows no more than 30 subs are required. Subs are just actually images. So you don't, if you go over 30, you're not benefiting anything particularly. I mean, you are a little bit, but it's a curve and it goes flat when it gets over 30. Stack using Sequitur, Deep Sky Stacker, or ASP. These are the probably the best of that. Sequitur is actually better for Milky Way because it deals with landscape pretty good, but it'll do regular Deep Sky. Deep Sky Stacker is probably the number one stacking program. Uh, ASTAP is actually the program that I use to do plate solving, but it also has a very nice uh, stacking program in it, and I use that sometimes. Deep Sky Stacker is what I primarily use. I do not recommend stacking images in Photoshop or Lightroom. They're not designed for astro images and they don't do as good. They stack, but they don't do as good a job. These other programs deal with noise and some other stuff a lot better. All right, shoot dark frames. After you shoot your light frames, place a cap on the lens and shoot 10 dark frames of the same exposure, temperature, and ISO as the light frames. Shoot those 10, and then when you stack, the stacking program will take those because the dark frames will show you all of the hot pixels on the sensor. And the stacking program will use that to subtract those pixels from the final image. It works very well. They'll be used in the stacking program. Okay, we made it. Next week, the same time, same place, I'm going to show you how I process these images using a stretching program called ArcSine Hyperbolic. Not a program, it's a system. And I highly recommend you come do that because you can go online, you can see all sorts of different ways to stretch. I've used nearly every one of them, and I'll be honest with you, this arc sign deal is just absolutely one of the best I've seen. And we're going to do a couple of things. We're going to use arc sign to stretch, and then we're going to use a program to take all the stars off the image, save them on a different layer, and then just process the nebulosity uh, and actually do it with camera raw. And then we're going to put the stars back on it. We're going to shrink them down, squeeze them, do whatever, get rid of some of them, whatever we need to do, and put them back on it. It's an extremely good system. I think you'd benefit from watching it.